Hi everyone, we're ready. Hopefully you've all had a nice lunch. Bruno's going to wake you all up again with his fantastic talk. So this is Bruno Sena. I think you've come over from Brazil?
Yeah.
Yeah, come all the way from Brazil. So please give him a warm welcome, a Bournemouth welcome, and I'll let you get started, Bruno.
So, thank you. Thank you guys, hello. Well, before you get to know me, you get to know my research, and I get to know you as well, I'd like to express my deep gratitude to all of BSides Bournemouth organization for allowing me to be here today. It's a great honor, and I'm really happy that my research on mobile hacking caught your interest. So in return, I really hope that everyone here in this room today could get at least 1 or 2 insights about mobile security, mobile hacking, and everything. So without further ado, let's get to it, because I have a lot to show you today. Well, my research is called God Mode Mobile, exploiting mobile apps with game cheats. And I'm going to tell you a story about how I managed to exploit a critical app using gaming hacker techniques. So let's get to it. A little bit about me. My name is Bruno. Hi. Born and raised in Brazil and still living there. I am working currently at Italian Security. I work with offensive security in general, but I have a focus on mobile security, a degree in computer science, and I've also have a hobby, which is game hacking. And that's actually how it all started, by combining these 2 things, which is my expertise on mobile security and game hacking, which is a hobby. And game hacking is actually what first brought me to cybersecurity in the first place. I'm also the creator of MobSec Crew, which is a mobile security and hacking community that I've created. And with MobSec Crew, I organize the mobile security villages and BSides São Paulo and other events in Brazil. So if you guys want any mobile village in the next years, here I am. And well, although I started my cybersecurity career by game hacking, I've never actually taken some time to actually explore mobile game hacking. And a few months ago, I decided to actually go through it and do some research on mobile game hacking. And as I was going and searching and came across like technologies and techniques, at some point, I began to wonder, how can I use these techniques? Could I use these techniques to actually exploit apps, like critical ones, like maybe a mobile banking app with these techniques? And that's what I'm going to show you today. So I started with this game, which is Assault Cube, it was a game originally developed for PC with this Cube engine, which uses C++. It's a very simple game engine, and because of that, it's a very simple game to reverse engineer to. And then it got a port for Android. Yeah, and as you can see, this is the Android version. Please don't mind, I'm a terrible player, but that doesn't matter. And as you can see, I can die, I'm a shitty player. So there's a lot of tutorials on the internet on how to hack and cheat this game, but in the PC version. So I decided to do it on the mobile version, on Android. So the first thing that I did was to open it in JDX to see some code. And as the game was originally developed for PC, all the game logic, it's not on the Java code, but yes on the libraries, the native code libraries that this Java code loads. So we can see here that we have main and server. So these are the game logic is contained on those native libraries. So as any other app, I used APK2 to decompile it, and apps that normally load native library, they are commonly stored in here in ARM64. So we have here our libmain.so, and our game logic is contained here. So with our libmain.so in hand, we can actually go through some more common game techniques, and we're gonna go with Ghidra. So I decided to look for some functions names like this. As I said, that Cube engine is a very simple game engine, so we can see all the functions with their names. So I went searching for some damage functions, and I came across this one with this address, do damage. And as we can see here, we can see the structure of our function. So we have the do damage. We have an integer called damage, which is probably the damage itself. We have two player entities, P1 and actor. So we can assume that actor is the player that it's inflicting damage, and P1 is the player receiving damage. We also have an integer for gun, which probably is the ID for the gun that is being used. And down there, we can also see a dereference for player 1. And if we go through it and look further, we can see that this actually is the static address of our character, our player. So this will be very important. So with this, we already have all we need. We have our address to our character. We have the function and we know how it works. And most importantly, we know how it fits together. So as we are in an Android environment, we're going to go with Frida. So here I develop a Python loader. What this will do, it will simply start our app, which is net.cubers.ace.cube. And then we'll attach our Frida script, which is assaultcube._god mode. So this is actually our Frida script. So what it is doing, it is finding the address of the native library, and it's saving on that base address variable. And then with this interceptor module, we can actually intercept and attach our Frida script to that native library. So that is the address that we found earlier. And here I'm just logging every time that this function, the do damage function is called, I'm printing the arguments. So the damage, the player, everything. Here, down there, we're also saving our pointer to the static address of our character. And then we're going to get the effective address, which is the address that is actually in the memory of our process. And here is where the magic happens. Basically, what I'm doing here is I'm saying every time that the player who's being damaged is myself, is my character, I'm patching the damage to 0. So what should happen here is every time that I got shot or everything, I will not get any damage. So let's see how this works. So I'm going to run my Python loader, which will start my Frida script. The game is already running. And they should be working by now. So our Frida is already running. So as we can see, I started on a common match. And we can see every time the function is called, when I shoot an enemy and when I got shot too. But see that every time that I got shot, the damage is being patched to 0. So my life doesn't change. But I can still kill the other enemies. But my life is not affected. So here, you can see a lot of patched damage to 0. But that doesn't affect the other players, just me. All right, but interesting, nothing particularly remarkable, but interesting. But what can we do with this? Well, after exploiting this game, I started to wonder, are there any apps that use this technique of load native library code into the process, and there are apps that probably were developed firstly for PC and then gained a port for Android. And then I went searching for it. And that's when I came across this app, which is KeyPass to Android. Basically, this is a port of KeyPass, which is a famous password manager software for Windows. And it was developed with C#. And this is an Android port. And as we can see here, although this is not an official port, we can see that it has a lot of users, more than 1 million downloads. So that's very interesting. And I'm going to do the same thing that I did with ASOS I'm going to open it on JDX, see the libraries that are being loaded with low library. And by looking at this, I was analyzing those libraries. And when I see this monogen, mononative, monodroid, I saw it and I began to wonder, well, I think I've already seen it before in some place. And then I remember where I've seen it. Unity. Unity is, for those of you who are not much into games, Unity is one of the biggest and most famous game engines. It is a cross-platform development framework for 2D and 3D games, everything. And it's scripting with C#. And Unity has two types of runtimes. One of them is mono runtime, and one of them is IO2 CPP. Basically, the difference is the compilation. Mono uses JIT compilation, which is just in time, and IO2 uses AOT compilation. In mono runtime, we have a moderate performance. What it actually it has a bytecode, which is called Common Intermediate Language, and this bytecode is executed on a VM, pretty much like Java, JVM. So it's executed on a virtual machine, and IO2CPP uses ahead of time compilation. It has a higher performance. It converts the intermediate language to C++, so it strips the original code, so it's very much harder to reverse engineer IO2CPP than mono runtime, because most of the time mono runtime it already keeps the original bytecode on the actual file, so it's easier to reverse engineer it. And that's it. So we're going to focus on mono runtime. And to do it, we're going to use a game which was developed to run on the mono runtime, which is Cuphead, developed with Unity engine and runs on mono runtime. So here we are in a pretty common gameplay where I can hit the boss, he can hit me. I think I've died here. I must die. But you can see that I don't kill him right away. So we're going to go through some game files. As I was searching through the game files, we can see the managed folder and the mono folder. So that mono folder also says to us that this game actually uses mono, but we're gonna not wanna search for it right now. We're gonna focus on managed. So here we see a lot of DLLs. We also see some mono DLLs, mono security, but we're gonna focus on assembly C# DLL, which is our main DLL, which contains all the game logic. So with these DLL, we can use another tool very commonly used for game hacking, which is dnSpy, which is a decompiler for DLLs and helps us to understand its structure. So here we opened the assembly C# on dnSpy. I went searching for damage too. So I found this weapon properties, level weapon P-shot, basic damage. P-shot is basically the basic attack of the game, that blue burst of fire that we shoot. Yeah, and I went through this damage, the class, and in the P-shot class we can see the actual damage. So we can see here. So I was thinking, what would happen if I change this value to something ridiculously high? And that's what I did. And let's see, and then I alter it. Let's recompile and see what happens. So well, actually I must do a lot of damage. So you can see that the boss can also hit me. That shot is not the P shot, but when we shoot the P shot, which is the basic attack, it kills the boss right away, like with one hit. This one, I hit him with the first time. It didn't kill him because I think that he wasn't able to get damaged by the time. So yeah, that's it. We hit everyone, we kill everyone with just one hit. So back to key pass to Android. We see those libraries, monogen. We also see Xamarin, and I will talk about it later. But all right, so we're seeing the mono libraries, the Xamarin, but we're not actually viewing the libraries that contain the key pass logic itself. So where are them? So I went searching a little deeper in the Android APK. I found this mono package manager, and I found these two functions: get assemblies and get dependencies. Both of them reach out to resources, the resources folder, assemblies and dependencies. So I went to the resources folder. Inside there was another folder called assemblies, and there was these assemblies.blob, assemblies.manifest. So let's see what are those. So when I tried to access assembly.blob, I got this file too large for view, so it didn't help me very much. But on assemblies.manifest, we can see a lot of names that they look very similar to what a DLL would be called. We can actually see those here. KeyPass to Android setup, KeyPass lib to Android. So, all right, we can presume that those are the libraries that contain the password manager logic. But how do we get them? We just have names and this blob that it doesn't mean very much. So I started to searching a little bit about Xamarin, because there's a lot of Xamarin libraries here. And basically, Xamarin is a mobile app development platform framework. It is based on .NET and C#, Microsoft framework. And basically, it is used to develop an app with .NET and things like that, and then makes a port for both Android and iOS. And most importantly, it runs the apps on Mono runtime. So I went through digging a little bit and looking for some content about Xamarin exploitation on Android. And I found this article, which helped me very much, from Go Secure. And it's talking about bypassing Xamarin certificate pinning on Android. So apps developed with Xamarin, they can implement certificate pinning, and this article talks about how to bypass it. So very briefly, what this code does, the most important thing about this article is that I discovered that there are actually a Frida module for Mono. So what this code is doing, it's just loading the target DLL, which is system.net.http. Then it looks for the class, the target class. So in this case, it is HTTP client handler. And once it's found its class, we can go searching for the actual method that we want to hook. So in this case, it is this create default handler and also message invoker. So all right. So we've hooked the Mono library. We found the target class and the target method. So what we must do now is actually hook it and tamper with it to do what we want. So what the code is doing here, it is actually changing the handler that it is creating for another HTTP client that will not actually validate the pinning. So very briefly, when it runs, without the script, the certificate pinning is validated and we do not get anything. But when the script is running, we got OK response. So very briefly, just to show you this Frida module to tamper with Mono and everything, and with Xamarin. All right, but back to our assemblies and assemblies.blob and manifest. How can we actually get those libraries, those libraries that contain our password manager logic? Well, that's actually very simple. In that article, they were talking about this tool, which is PyXamStore. And what it does, it's basically those two files, manifest and blob, they are used to parse the libraries into one single file. And this PyXamStore, it reverses it. So we can get by passing both the assemblies and the blob, the assemblies and the blob and the manifest. What this tool does is that extracts all the libraries contain that. So here we have everything that we saw before. So like Xamarin, and most importantly, right there, the key pass libraries. So right now, I think we have all we need. We know how to hook mono runtime with Frida. We know how to tamper with DLLs that we learned from Cuphead. We learned from Outside Cube how to hook into the process. So we can see that here that I've actually opened all the key pass libraries that I got it from the past two on dnSpy, so we can analyze it. Back to JDX, I was searching. I will virtually show you the actual app, the key pass Android. But as I was searching through JDX in the Android manifest, I found these two activities, which is password activity and quick unlock. Password activity is basically the activity where the user inserts submits his password, his master password, and then unlocks all the other passes he's storing. And this quick unlock activity is basically a feature on that app that allows you to unlock all your passwords without actually submitting all your passwords, just the last 3 characters. So the user can enable it or not. So as I was looking through that quick unlock activity, I found out that it relates to the key pass to Android setup too. So I can assume that this is the main library actually that deals with quick unlock functions. So I open it, the key pass to Android, which is what is called the key pass to Android setup 2 on dnSpy, and I went searching for quick unlock. And I found this method called onUnlock. And it's actually very simple. It receives an argument which comes from an edit text. So it's probably the edit text where the user actually submits his 3-character password, the last 3 characters of his password actually. Then it compares to that expected password string. And if it's equal, then it calls that unlock and sync and close. That unlock and sync and close is the actual method that unlocks the database, which has all the passwords. So let's go to our script. I don't know if you can see, guys, but basically what we are doing here, we're using that Frida module for hooking mono. We are hooking the Frida to our mono runtime. Then I'm enumerating all the assemblies to find the target DLL, which is that one key pass setup 2. Then I'm printing when I found the target DLL, which in this case is the Android setup 2, Android key pass setup 2, I think. All right, so when we found, I'm going to get a console log. Then I'm actually looking for the class contained on the key pass Android library. So we want the quick unlock class. Inside the quick unlock class, we want to locate both onUnlock and unlock and sync and close methods. So that's what we're doing here. All right, and we're looking for them, and then we're instancing those methods. What are we doing here? All right, so once we have found our target library, our target class, and our target methods, we can actually intercept it, just like we did with Outside Cube. So what we want here is to intercept both onUnlock and unlock and sync and close methods. And what yeah. So what I'm doing here is actually very simple. When the original code, the original on-unlock code is executed, it compares the string that we passed that come from the edit text, which is the 3 last characters of his password, and it compares to something he calls the password expected part. But what I'm doing here is that every time that the onUnlock method is called, I'm just calling onUnlock and sync and close right away. So it doesn't have to compare though any password. So if this works, we should unlock the database without any password. So I'm just printing here every time the unlock and sync and close method is called. And this is just me passing what is the target library that I want to find. Well, let's see if this works. So this is the key pass to Android, quick unlock. I just submitted a random password, and then I submitted my actual password, which is senha123. And here we have all the passwords that are being stored. I'm not running the script yet. So we saw that any password doesn't work. We have to actually submit the 3 last characters of our password. But when we run the script, we can see that it found the target DLL, the target class, and the target methods. So when I submit any password, it just opens it right away. So we can see that the unlock and sync and close was called. And just for you to see it, as we're not actually we're not validating any password. So if we actually open it and don't submit anything at all, we actually bypass it. And I've actually been more fast than I thought it would be. Thank you, guys. Any questions? Yeah, please.
What made you choose KeyPass?
I was digging through a lot of apps and searching for apps that actually were firstly developed for PC and then gained a port for Android. And I decided for this one because I saw there was a really big app with more than 1 million downloads. And I think, okay, I'll start with this one. And it was the first one that I've tried, and I already found this. So that's it. Yeah?
Have you looked much in terms of like API calls to, because increasingly I'm seeing a lot of games, they are basically putting things like user metrics and leaderboards into like built-in APIs. Have you done any exploration in that?
In this app, actually, no, because he's mostly offline application, so it doesn't communicate with any APIs. But in another app, which I forgot to put here, but I actually found many other apps that use these techniques, Xamarin, Mono, on time, and everything. So in an app with these technologies that both communicates with an API, this could be used to exploit it too.
Do you have to do this on a jailbroken device, or can it work on any device?
No, it can work on, well, I've actually run it on Android, mostly on a physical device. But any app, even in an iOS or another platform, we can actually use Frida too to hook on Windows, on iOS. So obviously it will be a little bit different, or the process to identify the DLLs and everything, but the logic it will be the same. Yeah.
For this to work, you would need the victim's device and then to have configured that unlock.
Yeah, the user would have to have it enabled. You guys might ask me why I could have actually done this like I did with Cuphead, which I actually just reverse engineer it and altered the damage and then repacked it, recompiled it. But what I wanted to show you is that by hooking it dynamically, is that if this app was in a device that was infected by some kind of malware, that malware could exploit this function dynamically. So it wouldn't, an attacker wouldn't have it wouldn't need to have physical access to the device because we could exploit it dynamically. Any more questions?